Welcome, everyone. My name is Katherine Watts, and today we'll be answering the question, can bodybuilders eat a vegan diet and gain muscle without use of supplements to build that maximum muscle? A common thought would be no, but let's see what the data says. What would you assume his plate looks like to gain muscle? Would it look like steak and eggs? Or would it look like this vegan plate? What is the recipe for muscle growth? Discussing completely plant-based diets that meet energy requirements for resistance training. Can it supply enough protein and leucine to maximize hypertrophy and strength in male bodybuilders? A modeling study by Goldman et al. We'll take a look at it from this angle. Let's go through this research in 4 sections. Let's start with the background. This is the core tension that motivates the entire study. On one side, you have the International Society of Sports Nutrition recommending animal-based protein for superior muscle building. On the other hand, you have USDA telling young men to cut out red meat and eat more fruits, vegetables, and grains. These two guidelines are pulling in completely opposite directions. That conflict is the gap these researchers wanted to fill. The researchers defined a plant-based diet as whole food plant meals with no animal products, no protein, supplements of any kind. They used fiber intake as a marker of whole food compliance, so the diet had to meet or exceed the fiber recommendations to qualify. That is the definition that makes the results more meaningful. If it works under these conditions, it'll work under the hardest versions of this test. Now let's take a look at the methods. The researchers needed a realistic physical profile to model from. They pulled median values from a systematic review of 235 competitive male bodybuilders. The profile they landed on was about 84.5 kilos and 28.5 years old, and 4 to 7 training sessions per week. They chose males specifically because males have the highest protein and leucine requirements of any athletic population. So if a plant-based diet can work for this group, it should be able to work for others as well. For the dietary pattern, the researchers needed real-world data on what vegans actually eat. They pulled from the Adventist Health Study 2, a cohort of nearly 5,700 strict vegans. This is the largest vegan dietary data set in scientific literature, which is exactly why they chose it. The diet reflects what real people following a whole food, plant-based lifestyle actually eat day in and day out. The key dietary characteristics from the AHS2 cohort: protein made up about 14.5% of total calories, and the fiber intake was about 46.7 grams per day, which is well above the general recommendation for fiber of 25 to 38 grams. That high fiber number is actually important because it confirms the diet is genuinely whole food based. Processed vegan foods would not produce a fiber number like it, so that tells you that the calories are from real plants. First, let's calculate how many calories a competitive bodybuilder actually needs while bulking. The base resting metabolic rate for an 84.5 kilogram athlete comes to 2106 kilocalories per day, using the Tinsley equation, which is specifically validated for trained athletes. We're going to multiply that by a 1.75 activity factor to account for the 60 to 90 minutes of daily training. Then let's add a 15% calorie surplus for the bulking phase. The result is an estimated energy requirement of 4,239 kilocalories per day. That is a substantial amount of food that is actually an important setup for why the protein numbers work out the way that they do. Since the AHS2 vegan diet is 14.5% protein, at 4,239 kilocalories, that works out to roughly 154 grams of protein per day, or about 1.8 grams per kilogram of body weight. The target they were testing against was 1.6 grams per kilogram, recommended by the International Olympic Committee for maximizing muscle growth. The leucine threshold that they used was 2 grams per meal, which is the dose established in the research literature for fully activating the mTOR pathway in young adults, which we'll get to in just a minute. Leucine is an essential amino acid found in dietary protein. High-quality protein sources that are particularly rich in leucine include chicken, beef, fish, tofu, eggs, and beans. The research confirms that leucine serves as both a building block for muscle protein synthesis and as a signaling molecule that initiates it. When dietary protein is consumed, digestion breaks it down into individual amino acids, one of which is leucine, which are absorbed into the bloodstream and delivered to the muscle tissue. Leucine enters the muscle cell and activates a sensor protein called cestrin 2. Cestrin 2 then releases an inhibitory complex called GATOR, which allows protein called RAG GTPases to pull mTORC1 to the surface of the lysosome, where it is fully switched on. The lysosome is the activation site. The signal is a precise location-specific event. So think of cestrin 2 as the sensor and the lysosome as the ignition point, and mTOR as the engine. Leucine is the fuel that starts all of it. Once activated, mTORC1 does two things at the same time. First, it triggers muscle protein synthesis by activating a protein called P70S6K, which initiates the translation of new muscle proteins at the ribosome. Second, at the same time, it also blocks autophagy by inhibiting ULK1 and ATG13. Autophagy is the cell's self-cleaning process, and mTORC1 shuts it down temporarily after a leucine-rich meal so the cell can focus entirely on building new muscle instead of recycling old protein. So mTORC1 is hitting the gas on the building new protein while also hitting the brakes on tearing existing protein apart. That dual action is a big part of why the anabolic response is so powerful. This brings us to protein balance. So, muscle growth does not happen just because you've triggered protein synthesis. It happens when the synthesis exceeds the breakdown, when the scale tips into that positive territory of, hey, let's build muscle. mTORC1 does both jobs. It drives synthesis up through the ribosome pathway and pushes breakdown by suppressing autophagy. That net positive balance is what physically thickens the muscle fibers over time. You can eat plenty of protein and still lose muscle if breakdown is running too high. The signal has to be strong enough to win both sides of that equation. That is exactly what the leucine trigger hypothesis addresses. Research shows that there is a threshold of approximately 2 grams of leucine per meal for young adults that must be fully reached to activate the mTOR pathway. Below that threshold, the signal is too weak to tip that balance. Above it, muscle protein synthesis is maximized and autophagy is suppressed, creating conditions for net muscle gain. Once you hit that leucine threshold, the anabolic effect is identical, regardless of whether that leucine came from a chicken breast or from a bowl of lentils. The cell really does not know or care about the source, it just responds to the dose. Now let's look at some of those results. There are four result categories in the study examined. Let's start with the energy requirements. The researchers calculated how many calories the specific model bodybuilder needs to build muscle by stacking three numbers together. They used the Tinsley RMR equation for athletes. They used the high volume training activity factor of 1.75, and then they added a 15% bulking surplus, giving us a total of 4,239 calories per day. Now let's review some of those protein requirements. For protein, the model study calculated that plant-based diets deliver about 151 grams per day, exceeding the required 135 grams. The relative protein level comes to 1.8 grams per kilogram per day, which surpasses the International Olympic Committee's recommended minimum of 1.6 grams per kilo per day. These are not small differences. The diet exceeds the protein target by about 12%. This was achieved through whole foods like legumes and grains. The green bars represent the modeled intake levels, and then the horizontal lines represent the targets. As you can see in each case shown here, the green bar clears the target line. Hitting 2 grams of leucine per meal activates the mTOR pathway and maximally stimulates muscle protein synthesis. So let's see whether a scaled plant-based diet can hit that target at each of our 4 daily meals. For leucine, the scaled diet delivers 11 grams per day total, or 2.75 grams per meal across 4 meals. This exceeds the 2-gram per meal threshold at every meal. Each of these 4 daily meals independently contains enough leucine to activate that mTOR and trigger a full muscle protein synthesis response. This is significant because the leucine trigger is easily exceeded at each meal. The vegan bodybuilder eating 4,239 calories of whole plant foods would be sending a strong signal 4 times per day. The study went beyond just protein and leucine. They also examined 18 micronutrients and essential fatty acids because building muscles while missing key vitamins and minerals would decline overall health and athletic performance. This table shows scaled micronutrient intakes compared to dietary reference intakes for 18 different nutrients. Of all the nutrients examined, only 2 fell short. Vitamin D came in slightly below the RDA at 536 IU versus the 600 targets, and this is actually common across all bodybuilding populations, not just plant-based ones, and this is typically managed through supplementation or sun exposure. Sodium was the other exception, coming in at 7,484 milligrams per day versus the 2,300 milligram recommendation. The authors believe that this likely reflects the overestimation by the Food Frequency Questionnaire, and that athletes who sweat heavily may have higher sodium needs. Everything else, including the vitamin B12, calcium, iron, zinc, and omega-3 fatty acids, met or exceeded recommendations. It is often a concern for vegans that vitamin B12 will not meet your RDAs, but as you can see with this meal plan, it certainly did. Now let's discuss what we learned from the study. So what does it all mean? Here are some of the key takeaways. Meeting protein and leucine requirements for high-performance athletes on a plant-based diet is achievable through sufficient calorie intake from a diverse whole plant foods. No supplements are required. The plant-based approach also offers cardiovascular advantages, and saturated fat came in at only 5% of calories, well below the 10% national recommendation. This is because bodybuilders as a population show elevated cardiovascular disease risk factors, although the authors note that cardiovascular disease may not only be attributed to diet alone. Two micronutrients still require attention: vitamin D and sodium. Vitamin D and B12 are commonly supplemented with plant-based athletes. Let's take a look at the strengths. So the dietary data came from the largest vegan cohort ever studied, nearly 5,700 people. This gives the model strong statistical application. Actual bodybuilder anthropometric data from a systematic review of 235 athletes was used rather than estimated values, and the Tinsley equation for the resting metabolic rate was selected because it is validated for athletes with a physique that is very muscular. Most standard equations underestimate energy needs for this population. The study modeled whole food protein sources rather than supplements, answering a question that previous studies relying on protein powders could not. This is a modeling study, not a clinical trial. So these results are theoretical calculations, not measurements from real bodybuilders in a lab. The baseline dietary data came from food frequency questionnaires, which have issues with underreporting. The model diet produces 99 grams of fiber per day. That is well over the recommendation of 25 to 38 grams of fiber. In practice, that volume of food could cause satiety challenges or GI discomfort for some athletes. The authors suggest that calorically dense plant foods like whole grains, nuts, and cooked legumes can help manage this. The findings also apply only the off-season bulking phase, so during the contest prep when the calories are restricted, supplementation may become necessary to hit these protein targets. The findings apply only to young adult males, so they may not translate over to female athletes or older populations with different protein sensitivities. While the study addressed protein quantity, it did not fully model protein quality or digestibility. The leucine trigger may also behave differently when leucine comes from whole foods versus isolated supplements, since digestion and absorption rates differ. Dietary creatine was not modeled because large plant-based cohort studies do not report it. This is a big gap since creatine supplementation has shown benefits for muscle strength and muscle growth. Finally, the high projected sodium level likely reflects overestimation by the food frequency questionnaires method rather than a true dietary concern. These are some of my observations. So the biggest takeaway here is that models are a starting point, not the whole story. A patient can look perfect on paper and still be losing muscle. Clinical presentation wins every single time. And keep in mind, there is a specific population this may apply to. Think malnourished patients with visible wasting who are actually eating adequately. The intake is there, but something is still not working. That is where the research gets a little interesting. You always have to try to address the individual individually. And one open question to leave you with is, would blending these same foods to lower the fiber content produce different results? That is a gap in the research worth paying attention to. So to close, the answer to the opening question is theoretically, yes. This modeling study demonstrates that a plant-based diet, when scaled to meet the energy demands of maximum muscle hypertrophy, can deliver enough protein, leucine, and micronutrients to maximize resistance training adaptations without protein supplements. This bridges the gap between chronic disease, prevention guidelines, eat more plants and less meat, and the sports nutrition guidelines. The study reveals that it is the dose of leucine that matters, not the biological source. Plants in sufficient quantities are biologically equivalent to animal protein for stimulating muscle protein synthesis. And these are my references, and thanks for joining in.